Hello, everyone. Welcome back. This is the usual stream for writing a programming language in Rust. This is, just a follow on from early on today where I was adding a couple kind of last minute features to this language. Mostly I was getting stuck into the, shall we say, kind of somewhat hacky, but still, I think, very reasonable approach for handling semicolon, eliding, elision. I'm not quite sure how to pronounce that, but being able to omit semicolons in this language. And yeah, it's a very interesting one. So I've actually been thinking about it for a long time today and hoping that I can make some more headway in it tonight. Now, I'm not intending to spend too long on this. Hopefully I'll be able to get through this, at least the main parts of it quickly enough, but we'll see how it goes. So just something that I'm thinking of here is that I wonder, can we handle some of this indentation without too much difficulty? One of the obvious ways is to have each block return a value and then continue processing. Now, the only thing is all of these else statements do the same thing, so it kind of feels like that will be the easiest if there was some common way of handling that case. No, I'm not sure. But with that said, what I was going to do now is just kind of go through each of these in turn, these test cases that are failing, and seeing, can I handle each one? So let's take a look at arg spread and see what exactly the issue is there. So we have this happening on line 6. And I don't quite see what's going wrong. As far as I can see, we should be outputting a semicolon at the end of each of these new lines. Okay, maybe it's happening. No, it should be skipped after this line and this line and this line. Okay, so maybe the problem here is that there's a semicolon being output at the end of, since there's a closing brace, we're saying that that was the last token. So what are we on? We're in fact on output a marker for each of these so that we actually see what case is being triggered in each situation. So we're saying last token and then current token. And essentially what we'll probably be seeing is current token is this. So we're saying if the current token is semicolon and the last token was brace open or brace closed, then we skip it. We also want to skip it if it's a semicolon. And that could actually resolve a lot of the other tests potentially. Yeah, that seems to be the test passing. So let's go ahead and comment out those lines again and see what that does for us when it comes to the rest of the tests. That's that. So let's go ahead and try running all of the features tests. So a bunch of those are still failing. The comments file is also failing. That's interesting. But let's take a look at function this first. What could be going wrong here? So we have a comma at the end of this line, so maybe that could be added. So if a line ends with a comma, then we don't return a brace, or we don't return a semicolon. So that may have caused some passes. Let's review. No, there was 29 passes before, and there's the same number now. I guess I better look at the last one first. So we have operation assignments. And what line is that failing on? Line 13. Oh, interesting. We have a closing brace here. So we could say that if the brace is on the same line that it was opened on, then we don't omit the semicolon, then we include it. But we're still not handling the case where it's an object. So that's a very interesting case, and if in fact a lot of those object tests may fail because of that as well. That's actually a very important one I hadn't fully considered. So let's take a look at the function tests instead. And that could just be the same issue as well. So that's the same issue anyway. Function this source, function this definition would have the same. This bind could be different. So let's take a look at that one. We have also function variables. So what's going wrong in function variables? Print was unexpected. Now, why is that? We would have expected a semicolon there. Interesting. So that's a case where we've omitted a semicolon, but it should be included. Interesting. Now, another option is to just leave the semicolons out of the grammar, but I feel like that could cause ambiguity, even just considering the case of objects versus blocks. So if I have an object here, and I just have that, in theory that could be an expression or an object, so it's kind of ambiguous, at least with the grammar that's there now, without some more definite rules about when semicolons can be omitted. So how do I address this issue more generally then? Because we have the case where we have these essentially blocks that are more like expression blocks, and then we also have blocks that are more like shall we say they're always going to be expression blocks, but we have some that are essentially part of control flow, which wouldn't end with semicolons, but then we have ones that are not part of control flow as such. They're more for defining functions and objects. Now, a hacky way of addressing that could be to look at the grammar and actually say that even if statements and the likes and loops should end with semicolons. And even though behind the scenes that would make the grammar slightly more ugly, because it doesn't have I guess it won't really matter to the end user as such, because those are going to be omitted, then it kind of works out fine. It'll be a background detail and we can have a comment to explain what's going on and why. So let's try that approach. Like I say, it's a little hacky, but it could be fine in the end. So like I say, we do have justification for why we can't just simply omit semicolons from the grammar itself, because there would be ambiguity between, for example, blocks and objects in particular. I mean, some approaches that can help get around those limitations are to take, for example, the approach taken by Python, where you use indenting to define blocks and things like that. And when that's the case, then and in addition to the change that I've just made, we no longer need to omit semicolons the end of, at the opening and closing of braces. Oh, but we would want them at the opening of, yeah, we would want to skip them at the opening of braces. So if a line ends with an opening brace, then we don't output a semicolon, but if it ends with a closing brace, then we do output a semicolon. But going back to what other approaches there are for avoiding ambiguity in the grammar, there's also the approach of, say, the likes of Ruby, which is another language that doesn't have semicolons at the end, and that uses a distinct syntax for blocks in general. So it uses name literals, so if, then, and then end to denote the beginning and end of blocks. So using those kind of approaches, you also, and we have the test passing here, so I'm going to run it on all the features tests. But with those, oh, so that's most of the test passing now. That's kind of nice. But with those more explicit grammars, with the likes of Python and Ruby, you're kind of modifying the grammar to accommodate the lack of semicolons. Now, I'm not sure that was necessarily why those grammars were selected, but that is something that could be done to the grammar to make it more explicit and to allow for omitting semicolons. So let's take a look at variable scoping. So this is just a regular block. So again, we will allow just regular blocks in the grammar to end with semicolons. So that seemed to resolve that one. We also have comments giving issues. So we did output a semicolon even though one wasn't expected. So we have output a semicolon at the end of a comment line. I'm not quite sure where the failure is happening with that one. So let's take a look at multi-statement. Oh, that's just, I accidentally left the semicolon out for some reason. Okay, so character 6, unexpected, semicolon. that should be all that's needed there. So what's happening when we have a comment? So we're going into this section, which is going to keep checking for characters. We're going to see the pound symbol, and then we're going to keep looking at characters until we hit the new line character, which is going to break out of this loop, which is going to bring us back to the top here, and then we should get none at this point. Possibly for the end of the program. And that last piece, that's just because the declaration symbol isn't present. So let's take focus on just comments at the moment. So if we unmark all of these, because I believe it's going to return none at the point of, well, at which point? I'm not so sure yet. So we're hitting here anyway. So here we would say if let token semicolon is equal to t, otherwise return that. No, we want to go to the next character. So let's try that. Yeah, so that gives us the output that we're looking for. And at that point, we can basically remove semicolons from all the tests. And we'll also have some tests for just checking for omitting semicolons. So we'll call them multi-line tests perhaps. So this will just be an example of one. So again, these will be tests for when there are operators. Then we can just basically put whatever we want. And until there's a line that doesn't end with an operator, it'll just keep chaining them. So now the actual result of that kind of a computation would be what? So we have, I believe, left to right. Maybe I'll just do it like this to simplify it. So we have 3 multiplied by 4 will have the highest binding, so we'll have 12 minus 12, 2 minus 12 will be 10 plus 1. In theory, that should be 11. But anyway, I need to remove features from the test filter. We're just going to run it on all tests now and remove semicolons from all tests. Oh, it looks like I've some leftover junk in one of the tests. Oh no, that's an unused file. Thank goodness. I was gonna say, I'll just remove semicolons from some files to begin with, but the problem there is that the full, we're not testing features one at a time anymore. This change affects the whole language, so any tests that don't use semicolons are going to fail. So it benefits me to actually apply this fairly exhaustively. But having said that, based on the fact that the features tests all pass now, kind of means it's kind of looking good for the rest of the tests in general. That's a pretty good outcome, I have to admit. And in fact, one of those tests is one of the new ones that I added that I don't even have full support yet for. So that's actually pretty good. So let's take a look at the two error failures that are still happening. So we've got operations and Boolean precedence. What's going wrong there? Okay, so this would be an example where when we're inside a list or a parameter list, then we don't want to output semicolons. Now, the only thing to consider is, are there ever going to be times where we can have unbalanced parentheses and braces? And theoretically not. The only time that could really happen is if there was a string. But in the grammar itself, they should always be balanced. And let's take a look at parse errors. That's possibly just the that's something different. That's something that'll need to be addressed specifically. That might need to be changed to, let's try that. Yeah, so we are getting unexpected EOF again. It's just the characters that were expected this time around are different. So we have open paren, hyphen, we allow for dot dot, square bracket, break, continue, false. So potentially a wider selection of literals. So we have false function for identifier int literal. Oh no, we skipped there. Interpolated string literal, null return, string literal, true while, opening brace or closing brace. Let's try that. So I have identifier, but I shouldn't. No, I don't have identifier, but I should. I'm not sure. So the original doesn't contain it. Oh no, the output does contain it. So it should be for identifier if. Int literal, interp string, null return, string literal, true while, and those. Let's try that. Cool. That is sorted. And then we also had the operations Boolean precedence, and that's just to do with being inside the bounds of either a block or a parenthesized operation or something like that. So let's go back into the Lexer, and this handling for this would actually potentially handle the case of brace open being ignored as well, so it might actually simplify what we're doing. But first of all, let's take a look at latest token, and we'll also add in a new field. So again, this is one that will be tricky based on whether the thing that we're within the bounds of is expression based or statement based. So if we consider the likes of parameter lists, a parenthesized operation, or a list of values, the item as a whole is an expression. But then if we consider things that could be bound by braces, so objects would be an expression, but then blocks wouldn't be. So we actually... But there's also the case of nested expressions. So it can't be as simple as just knowing if we're inside a parenthesized expression or not. We have to keep track of all the different things that we're in the middle of and maintain a stack of opening and closing parentheses and different types of brackets. So we can say that for the expression-based one, or sorry, for the statement-based ones, which is essentially braces, we can take the approach that we've already been taking, which is that the ending brace of basically any of those is allowed to be followed by a semicolon. So whether it's the end of an object or the end of a block, then it's kind of going to do the right thing. So we just have to handle now the cases of expression-based ones, which are going to so if we have an expression-based one, we can keep track of the open, I guess, parameterized items or parenthesized items. So I'll just call them open sections for now. So we can use a vector using push back and pop back. And that's going to be of tokens. So I will shuffle this part around and say that this goes on the outside. Let's try that. Now that's going to be an error because I need to declare that. Cool. Glad to see that that has simplified things somewhat, but tests are still passing. So let's go ahead and try this. So let's see. We'll match T. And if it's a parenthesis that's open, or a bracket that's open, then we're going to push a copy of T onto self. Otherwise, if it's a paren close, then we will attempt to pop back. And presumably those will return options. They're probably pop and push. Yeah, so that'll return an option. And so if that's none, then for the moment we'll do a panic. If it's if it's none or see if it's parentheses open, then that's fine, otherwise it's very not. And same for brackets. And then finally, we're going to say that in addition to these checks, if it's not empty, basically if we're in the middle of a section, then we won't output a semicolon. So let's try that. It possibly would be useful if we had some distinction for objects versus blocks, and that would allow us to simplify things a little bit further. Some options could be to allow for a prefix on objects. And in fact, in some cases, in the language that I'm thinking of as a follow-on for this language, there will be a special prefix for objects that are mutable, but it will also be possible to define them without that prefix, so it still kind of comes back to the same thing. So that's interesting. Functions callback is now the only one, and that's not one that was problematic before. Okay, so we have a function literal, but it's inside a parameter list. So we actually do have statements inside parentheses, and in fact that could also happen within a list. So we can actually have statement blocks in any location, so this approach isn't actually viable. So what we might need to do then is basically go back to this slightly more primitive approach and just say if it's an open bracket or an open parentheses, then we skip it. And similar for when we encounter a new line after an operator. Yeah, and that works fine. It actually does the job. And in fairness, it's not a lot of extra code, especially once I clean it up, on top of what's already there. Okay, so I actually have partial equality defined on tokens, so I can actually just do something like this. To simplify this part at least. So let's try that much. I'll just sort these guys. And yeah, like I said, that kind of gets us a lot of the way to where we want to be. So I'm actually going to create a new branch and commit what's there. And of course, the documentation will need to be updated as well. So I just need to double check for any use of semicolons in the actual language of the docs as opposed to the code, because in the code it can all be removed, but not in the actual English. So I'm just going to go ahead and add all the test files, but I'll be a bit more thorough with the checking of the source files. So I think latest token is a bit simpler now. I think it's really just the last token that was read. And I can re-enable Clippy as well, which is what I was doing by removing the changes on the just file. Okay, so it looks like all the Clippy changes were also fine. So it looks like we're almost ready to commit in that case. So we no longer have this rule. So we add some extra description as to why we break on a new line. Cool, so despite the fact that we actually added semicolons to more sections of the grammar, because there are rules to automatically inject those semicolons based on different rules, in effect we omit semicolons from the language in general. So now we don't really have the rule that Python has, where we can, for example, omit semicolons from multi-line strings. We end up with, again, a similar structure to what there is in Go, where you have to have an operation at the end of the line to invoke a kind of a line continuation. But I think that actually is better for us in the long run. Because ultimately, if we take a look at the likes of Python, you can't have multi-line lambda functions, for example, and anonymous functions. Whereas even though we have maybe slightly stricter rules for when semicolons can be left out of parenthesized lists and regular lists, the rules are slightly more, they're stricter in one sense, but potentially allow for more uniformity and more flexibility in other ways, potentially. So where do we have, so we're encountering the same situation here where we have inserted a semicolon here, but we don't want that. So if we have encountered an operation, then we don't want to insert a semicolon in that case. And are there any other situations? So in the case of a return, we don't really want to allow that, although I don't think it makes a huge amount of sense to split a return onto 2 lines anyway. So maybe I'll just be a bit fussy and say that return has to be followed by an expression on the same line. Most of these, so with else ifs and things like that, that will use the operation continuation shortcut. If we have a function that can't be split except using the regular rules in null return, all of those I think are fine. So we'll have, division and we'll allow for example, function chaining. Or even property chaining. So we'll say x is equal to a, which contains b, which contains c. And we can do y is equal to a dot b dot c, which isn't a good demonstration of this, but it's fine. So we'll have dot equals, I think. So we'll have similarly greater than equals, less than equals, mod null, sum amp bang equals colon equals is for a statement. We can allow that too, and same for equals. So we had sum, sub, mul, mod, and we also need div. Okay, so we have a few failures here. So what's going on? So we have the value of operators. In theory, I feel like that should bind first. And then we do 2 minus 12, which is minus 10 plus 1. Yeah, so that should be minus 9. It's just my math earlier was off. We have declaration assign. Where is that? Oh yeah, that's exactly right. So it should have been an assignment second, and then in chain A is not declared. That's right, because it should be X. So let's try that. That's basically it for eliding semicolons, which was I'll admit, a lot more straightforward than I was expecting. Now, as some people have pointed out, the approach that was taken here possibly could be considered on the hackier side, but at the same time, the number of changes that it required was so small that it kind of makes up for how hacky it is. And also the nature of the hackiness itself is kind of confined to a little driver method, which just wraps around the main logic for handling tokens. And finally, what I would say is that the logic itself is relatively straightforward in the context of grammars, where I would say that people looking at the code would be fairly used to semicolons in the place that they're being put in this language in general. And so the logic of automatically inserting semicolons at the end of lines, except in the case of these special rules, I think the logic is actually quite straightforward and therefore fairly easy to understand by someone who's used to looking at languages like this. So it kind of makes up for the hackiness in a large way. I think I had something else to say on that as well, but I've kind of lost my train of thought. Yeah, so overall, even though, like I say, it could be considered hacky, it's fairly well contained enough that I'm really not too bothered by the hackiness of it, and I think it's actually quite an elegant solution, not least because of the fact that, as I said before, this approach allows us to keep the language fairly unmodified, so I haven't had to rework the language. And there definitely would be ambiguities in the language if I were to just naively take out semicolons. And the reworking of the language to allow for omitted semicolons, number one, would be fairly time consuming and would potentially need extra either directives or tokens or other bits and bobs added to the language in order to make it non-ambiguous, especially with regards to distinguishing between blocks of expressions versus objects. So because of all of those factors, I'm actually pretty pleased with the solution as it stands. Now, having said that, I should possibly put my money where my mouth is by actually just trying it and seeing what would happen if I were to just remove the semicolons from all of these sections. In fact, I'll just do it like this. Or rather, like this. And let's just see, will ladder pop flag any ambiguities in the grammar? And that would be a yes. I may be waiting for quite a while for that to exit, because I think there, yes, will be a large number of ambiguities in the language. Thankfully, that has finally finished processing, so I'm going to go ahead and reintroduce the semicolons here. But with that done, that's basically the language kind of wrapped up. So there's some changes that I want to introduce with Ash. So that's done. Define custom result. I might do that shortly as well. This is something that also still has to be done. But yeah, that's basically all the features. So that might be nice, alright, to do a series of videos how to extend the language, for example, with switch statements and pattern matching. Adding consistency around different terminology, that probably would be good to do, because the longer I leave it, the less likely it is to be added. Now, it's not an essential thing, which makes me want to put it off, but it could be nice to just add some consistency around the code base. And yeah, so that basically is the language finished for the most part. So I might have one or two other streaming sessions where I just take off some of the last few bits, such as defining a custom result, adding consistency around different bits of terminology. But yeah, that's more or less it for for this current language called Seed, which is a pretty good place to be, I think. And that'll need to be changed to omit the semicolon. Yeah, nice one. So yeah, same as last time, 90 commits. I think I need to push the main branch as well. And whether I will merge the semicolon changes into the mainline branch or keep it a separate branch, I'm not fully sure. That remains to be seen. But yeah, that's a pretty nice place to leave it for the moment anyway. So as always, thanks to everyone who is checking this out, and yeah, have a good day, and I'll talk to you again. Take care.